Okay, the recording is in progress right now. So, welcome everyone once more to the lecture 5. And today we would continue from where we stopped. And basically, where we stopped last time, I would in fact do more like a preview as to what we discussed last class, which was yesterday. So we started looking at the Soroban smart contract, and we started understanding the reason for the Soroban smart contract. We started seeing the advantages of the Soroban smart contract. And in fact, we understood the definition of a smart contract, understanding that smart contracts are a bunch of codes that executes based on the commands it's giving. And then we understood how important it is to not write a buggy code before you deploy a smart contract. We also understood or briefly spoke about why auditing a smart contract is important before you deploy it. And then we moved into the introduction to Soroban. Soroban is literally the smart contract used to, it's literally the framework built with Rust to write the smart contract on the Stellar network. So Soroban allows you to write and deploy smart contract on the Stellar network, and it is literally a framework built with Rust. We understood more about the Soroban smart contract, the features of the Soroban smart contract, how the Soroban smart contract is executed, understanding the low transaction cost of the Soroban smart contract, how scalable writing Soroban smart contract is. And in fact, we understood why it's important to even use Soroban smart contracts on the Stellar blockchain. We also went on to see the benefits of using the Soroban smart contracts, as we spoke of the enhanced functionality, the robust infrastructure, the community and ecosystem, which I in fact made mention of this particular class we have today. Then next, we went on to understand what exactly your smart contract is compiled into. And in the last class, we saw that your smart contract is compiled down to what we call a web assembly. Now, from yesterday's class, I explained that for a blockchain that allows the deployment of smart contract on it, that means it has a virtual machine where it executes the smart contract. Now, I made mention of EVM compatible blockchain, and I used Ethereum as an example. And I made mention that for Ethereum, the Ethereum virtual machine, the EVM is where smart contracts are being executed. Now, coming back to Stellar, for Stellar, Stellar also have a virtual machine. But how exactly does the Stellar virtual machine execute the code or the smart contract that has been compiled down to WASM? Well, we got to understand from yesterday's class that the WASM is stored somewhere in the ledger. So the ledger is basically a block that makes up the blocks of blockchain for Stellar. In Stellar, we can basically call it a ledger connected to another ledger, that makes up the Stellar blockchain. So whenever a WebAssembly code is deployed to the Stellar blockchain, what it does is it is stored on the ledger. And so whenever you want to write a call to the smart contract, all you have to do is instantiate the call, and then the call goes right to the ledger and it brings out that particular implementation, because the WebAssembly contains the implementation of the smart contract. So it brings back the implementation and then it executes it on the Stellar virtual machine. Then we understood what or how a smart contract deployed to Stellar works. What do I mean by this? We understood that In other blockchains, I would usually use EVM, as the EVM blockchains are usually more like the familiar ones when we are to compare blockchains as to how this particular system work. So for EVM blockchain, whenever a smart contract, for EVM, they use Solidity for writing the smart contract. So whenever you're done writing your Solidity smart contract, you compile it. And whenever you compile it, I made mention that it is compiled down to what we call bytecode. Then these bytecode are then executed on the Ethereum virtual machine through what we call opcodes. So the bytecodes are made up of opcodes that are then executed on the virtual machine. Now, in Stellar's case, Stellar, the WASM bytecode, which is what is compiled down to, which is what the smart contract is compiled down to, is then pushed, deployed to the Stellar ledger. And then the implementation functions you call in your smart contract is then called from that implementation. But how then is this done? Well, whenever you deploy your smart contract to the Stellar network, you have to do one more thing. You have to do what we call instantiating. So you have to instantiate a new instance of the smart contract. So instantiating a new instance of the smart contract, I made mention that that instance then have a storage. And what does that mean? That I used the illustration of an hospital. Now imagine I have an hospital, Nomad has an hospital. Now, Nomad have a different set of patients. I have a different set of patients, and we want to have the data of our patients stored on the blockchain. So the implementation functions that modifies the state of the ledger is what the WASM is. So now for me, I would come after the WASM has been deployed to the Stellar ledger, I would come and then I would instantiate an instance of it. Instantiating an instance of it means I now have an instance of the WebAssembly code, and so it has its own storage. So having its own storage means that, for example, my own the smart contract includes storage whereby you can store the names of the patients. You can store the names of the data of the patients, whether the patient's genotype, the patient's blood group, and all of this. Imagine I have 10 patients. I have functions that modifies the states. Okay, a new patient is added and it modifies the state of the data and the storage. Nomads can have our own smart contract instantiated from the same WebAssembly bytecode that has been deployed on the ledger. So in this case, whenever Stellar wants to update her own amount of patients or patient record, our smart contract still refers to the bytecode, the WASM bytecode that has been deployed on the ledger. So it refers to the implementation of the WASM bytecode, but it modifies the storage of our instantiated smart contract. Then for my own case, the WASM bytecode is also the implementation I use, but the storage of my instantiation is completely different from Nomad's own. This is because we both share the same implementation, but different storage. In EVM compatible blockchain, they call these factory contracts. So for EVM, the ability to create new contracts or deploy contracts again using a contract is called factory contract. But then that is completely different from Stellar. In Stellar, you would have to basically push that code, and all you have, after pushing the WASM bytecode, all you have to do is then instantiate new instances, and then you have new instances of this. And obviously, whenever you push the bytecode, that when I say push, understand that I'm talking about deploying the WASM bytecode after compilation. What then you have is the hash. The hash is literally the unique identifier associated with the smart contract. So it is this hash you will then use to instantiate a new one, and then this hash also is what you would use to get the implementation for the instantiated smart contract. So all of these are basically what we discussed yesterday. And then we stopped by talking about the contract instances. So today, we'll be talking about something connected to yesterday's lecture, the contract storage overview. Now, remember, we made mention that the WASM code is stored on the ledger. And because of this reason, because of this very reason, it is easy to instantiate new contracts, and it is basically easy for you to refer to the implementation. But then, all of this is stored in a storage. Are there different types of storage on the Stellar blockchain? Yes, there are. And that is exactly where we will be talking about today. Contract storage overview. In Stellar, there are different types of contract storage. The smart contract on Stellar can utilize different types of storage to maintain their data and state. The main types of storage include the temporary storage, the persistent storage, and the instant storage. What exactly is the temporary storage? What exactly is the persistent storage? And what exactly is the instant storage? All of this is what we are going to be discussing in today's class. But then, what is the importance of storage in smart contracts? Proper storage management is crucial for the functionality and efficiency of smart contracts. What does this mean? This means that different smart contracts are deployed or created for different use cases. Now, different use cases would then need different storage types. So that means a smart contract that might not live long or that might not be used for long, it would not be used or compared to a smart contract that would be used for long. So now there are certain smart contracts that works with time frame. An example of this type of smart contracts is probably a launch pad. Now you can have a smart contract whereby it's a launch pad, and we understand what a launch pad is. I would explain what a launch pad is. A launch pad is basically more like an IDO, ICO for people that want to raise a particular amount of money for tokens. And now for raising this amount of money for tokens, they then make use of a smart contract whereby those people that participate in the IDO or ICO after the TGE, then they can basically collect the new token that has been deployed. Now, for this kind of smart contract, it is time-based. So that means after that TGE, the smart contract is no longer useful because the money that the people contributed or participated with for the token launch, the money is removed by the token creators. And then those people that participated, the new tokens, that the code token, is then also removed from the smart contract. In that case, the smart contract does not live long. So after a while, the smart contract is not needed. So immediately after the TGE, the smart contract is not needed. So that is an example of a smart contract that is not needed for a very long time. But then, should we keep this type of smart contracts persistent on the blockchain? Now, another example of another smart contract is, in fact, the one I have made mention of earlier, the hospital smart contract. Now, the hospital smart contract is one smart contract that has to live long because the patient data, new patients come, and even as long as patients are not dying, or even if the patients die, the data still is there. And so whenever new patients come, the data is also added to it. And for this reason, the data has to keep on going. And that kind of smart contract would have to live long. So for that kind of smart contract, would you want to use a temporary storage for that type of smart contract? Then the answer to that is no. So now, let us go to understanding the definition of a temporary storage, a permanent storage, and an instant storage. What then is the definition? Temporary storage. Before I continue, I would want to check if everyone is still with me. Okay. Everyone is with me, right? Okay, great. What is a temporary storage? A temporary storage is used for data that is short-lived and does not need to be preserved permanently. I feel the name temporary storage already identifies what it does, and it is easy to understand it. A type of storage that is short-lived and does not need to be preserved permanently. It is the most cost-effective storage option on the Stellar network. We have explained why a contract might not need to live long based on a use case. And I used the example of a Launchpad smart contract for that. Now, one might think, why exactly then? Since the smart contract is not living long, fine, that's fine. But I mean, the blockchain is to keep records and data. Why is it not just there? Well, for a full network, if we can cast our mind back to when we spoke about a node, understanding what the node does, understanding how a node downloads the full client of the blockchain network, and how this blockchain network is what runs decentralized in a decentralized way in different parts and what forms the blockchain. Now, for different individuals that wants to join a particular, that want to join as a node provider, it is usually good when the amount of size of the data they are downloading on their node. So when we say node, as I made mention of last time, it is basically your computer, your laptop. So now I made mention from that class when we were talking about node, I made mention that okay, I heard the sound. Okay, yeah.
Raise their hand. Yeah, someone raised their hand.
Your mic and speak. Malik?
Maybe it was by accident.
Okay, so I would continue. Now, I made mention that these nodes have to download. Did I hear the sound again? Okay, it was a mistake. So I made mention that this node have to download the full client. And when I say the full client, that means the full blockchain on their local machine. And if they are not using a local machine, if they are using probably a cloud server, then they have to download it the full there. And when you download the full, you have to download it before you now start participating in the consensus mechanism, in the validation of transactions. Now, all the previous data on the blockchain are stored. As I made mention of, what makes up a blockchain is the total blocks connected to blocks that makes up the full blockchain. And if you can remember a class, I in fact illustrated what the blockchain looks like. Now, all of these transactions are data. And as time keeps going on, this data keep increasing, 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 and increasing. And the fact that it is increasing means that you have to get more spec. You have to increase your specification for running the client for you to join the network. But Stella thought that, why do we have to keep doing this when there are smart contracts that are not even needed to be on the blockchain after a while? And that is exactly why they thought of temporary storage. And for this, the smart contract, the data is short-lived and it is not permanently preserved. Does that make any sense? Does anyone have questions concerning that? Does anyone have any question concerning that? Okay, I would assume no one has questions since I cannot see any hand. So what then is the fee structure? Temporary storage incurs the lowest fees compared to other storage type. And this makes sense. because you are not having to, store your or deploy your smart contract wasn't bytecode on the Stellar blockchain and having it stay for a very long time. So it makes sense that the fee incurred is lesser compared to someone that would have his data on the blockchain for a very long time. So you cannot compare it. The fee definitely is lesser. And this makes it ideal for storing empirical data that does not need to be retained for a long time. This literally makes sense. Since you aren't using the data for a long time, the fee you pay will just be smaller for this short period of time. Use cases for temporary storage, suitable for time-bound data such as price oracles, signatures, or any data that can be easily recreated. Price oracles are data that literally changes. They changes, and the fact that they change means that they are not persistent. And this is in fact a suitable example, a suitable use case for this. So it is ideal for scenarios where data is needed for a short period and can be deleted once its purpose is fulfilled. And that is all about the temporary storage type. Moving on, persistent storage. In fact, from the word persistent, it should give an intuition of what the persistent storage is. What exactly then is the persistent storage? The persistent storage is used for data that needs to be retained for longer period and is critical for the contract's functionality. So compared to temporary storage, persistent storage ensures that the data can be restored if needed. So for temporary storage, the data is wiped out. For persistent storage, the data is retained for a long period of time. An example of this is that medical record smart contract that I've made mention of, and it's a perfect example for persistent storage. The fee structure, definitely what is persistent and what needs to be on the blockchain for a longer period of time compared to the temporary, the fee is definitely going to be increased. And this is because persistent data means the data is quite important and the durability is quite important. So the fee definitely is higher than that of the temporary storage. Use cases for persistent storage, suitable for storing user data that cannot be temporary, such as balances, user profiles. Example is that medical record I've just made mention of, or any critical contract data that must be retained. And so it is ideal for applications where data integrity and longevity are crucial. So it's just easy to grasp like that. So the persistent storage is more like the opposite of the temporary storage, whereby persistent storage, the data must be there and it's basically used for something important. And obviously, the fee is definitely higher than that of the temporary storage. What then is the instant storage? Well, the instant storage is a specialized form of persistent storage tied to the life cycle of the contract instance. What does this mean? This means that it functions similarly to persistent storage, but it has a limited amount of storage available. So unlike persistent storage, even though instant storage is persistent in a way, it has, sorry, I'm hearing some sound and it sounds distracting. Okay, I would mute you. Sorry. Sorry, can you mute Eric? There is a sound
Oh,
that
yeah,
is
let me
coming.
see. Yeah. Oh, he got it.
Okay. So for the instant storage, it's just like the persistent storage, but the instant storage has a life cycle. And so that means it has a limited amount of storage available to it. So let's say you have a smart contract, and then the smart contract, you want to use an instant storage. That means for the smart contract, the amount of storage allocated for it would be limited. So it will be limited compared to persistent storage. But then it does not mean it would not be persistent. It will be persistent, but the storage would be limited. Now, what does storage means in this sense? I have explained it before, but I would reiterate it as repetition is the master of, of understanding and mastering something. So yeah, the storage is basically referencing back to the illustration I gave about me having an hospital and also Nomad having an hospital. The data of the patient, the way we wrote it in the smart contract, the way the data is aligned, that is the storage. And this storage is mutated based on how the functions are called. And so this persistent storage, this instant storage, is different from the persistent storage in that it has a limited amount of storage available. So instant storage incurs the same fee as persistent storage, and this makes sense because basically the instant storage is also persistent, just that it has a limited amount of storage available. And this reflects the importance of maintaining the contract instance state throughout its life cycle. What are the use cases for instant storage? It's suitable for storing shared contract states such as admin account, contract metadata, and other essential data. In your own time, you can think of different smart contracts you want to build and then think, the smart contract I want to build, would I need to use a temporary storage, a persistent storage, or an instant storage? Well, it is based on the implementation and the use case of your smart contract. But for instant storage, it ensures that the state of the contract instance is maintained and accessible as long as the instance is active. Operations and transactions. What are operations and transactions in Stellar, on the Stellar network? Well, operations are individual commands that modify the ledger. Can you remember what the ledger is? The ledger is literally the blockchain. The Stellar blockchain is the blocks, is the transactions, is a block that is made up of transactions that is added up to the blocks. And all of this is what the ledger is. In fact, in today's class, we are going to see what the ledger looks like. Sorry, the sound is still okay. In today's class, we are going to see what a ledger looks like. In fact, we are going to check a Stellar scan and see what a ledger looks like and the structure of a ledger. This is what we are going to see in today's class. But then, what are operations and transactions? Operations are individual commands that modify the ledger. So that means that whenever you send a transaction to the Stellar network, that means an operation has modified the ledger. What does modification of the ledger means? This means that the state of the blockchain has been changed. So that means whatever transaction is being sent can be different. Now, if you remember in previous class, we made mention that there are different types of transaction. A transaction can be transferring the native token, that's the Stellar native token, that's XLM, transferring XLM. It's a transaction. Transaction can also be deploying a smart contract. It's a different type of transaction. Transaction can also be calling a smart contract, making a write call to a smart contract. That is also a type of transaction. Now, in previous time, going back to this slide, there was a particular operation that we made mention of, and I want to get that operation. And if you can remember from yesterday's class, I talked about that operation, and I said I was going to get deep down into the operation and understanding what operation is, as it was important to understand what operations on the Stellar blockchain is before then explaining this. So I made mention of the contract data ledger entry. The contract data is one of the operations, and the operation is used to create and store binary data of a smart contract on the ledger. So that means whenever you want to deploy a new smart contract, you want to deploy the WASM bytecode, you call an operation. And so the operation you are calling then is the contract data operation. And this contract data operation, what it does is it modifies the state of the blockchain, obviously, by doing what? By adding the bytecode, the WASM bytecode of the smart contract. Operations. So each operations perform a specific function, such as sending payments, creating accounts, or invoking smart contract functions. And this is exactly what I've made mention. And since we've made mention that as long as you modify the state of the ledger, the state of the blockchain, that means that you have performed a transaction. And these transactions can be in any form. And for perform any of these transactions, you have to do something. You have to use one of the operations to modify it or to perform it. Definition and examples of some operations include payment up, create account up, change trust up, and invoke host function up. So each operation type has its parameter and the effects on the ledger. And for this, I would stop sharing my screen, and I would want to share the official documentation of Stellar, and I would want to use this to do more explanation on operations. Can you see my screen now? Yes. List of operations. As made mention of, operations are objects that represent a desired change to the ledger, which is the blockchain, and then is submitted to the network groups in transaction. For each operation, there is a successful or a failed result type. This is whenever you send a transaction to the blockchain, you definitely must expect something. It is either successful or it is failed. If it is failed, that means it is not added to the list of transactions or the modification of the blockchain. Now, for different types of operations, there are different results, error code for it. Now, for the create account operation, what does it do? It creates and funds a new account with the specified starting balance. So here is the parameter of the create account operation. It has the destination, then it has the starting balance. What are the possible errors that can come from this? We have the create account malformed, create account underfunded, create account low reserve, create account already exists. So now, whenever you see something, an error like this, you understand that this transaction has not modified the blockchain, and then you can understand the reason why this operation that you called the create account could not go on. Another operation is payment. For payment operation, what it does is it sends an amount in a specific asset to a destination. So for all of these operations, you can use different SDKs to write it. If you are a JavaScript developer, you can use JavaScript. You can use JavaScript. If you are a Java developer, there's opportunity for you to use Java. And if you're a Go developer, there's opportunity for you to use this SDK to perform this operation. So that means that you can make different transaction operations on Stellar using these SDKs. And in our case, after we've learned how to write the Soroban smart contract, and we've learned, obviously, the first step is learning to write the Rust language, as that is what will help us write the Soroban smart contract. We will move on to writing with JavaScript, writing and using the SDK with JavaScript. And so this is what we are going to use. And in fact, during that time, we are going to see how we can use some of these operations to modify the ledger of Stellar. And for this case, this is payment opcode, the part payment street send. So there goes on and on, different operations. And it is interesting. It makes life easy for you as a developer. When you come here, you understand that all of these are the parameters that goes into the function you are calling, this particular function you are calling for the operation. You pass in the parameters, the send assets, the send amount, the destination asset, the destination mean, and the path. Once you send all of this, and in fact, interestingly, the description of what all of this means is right there. So once you send all of this, if the transaction is not going through, there definitely would return one of these 12 errors. And you can easily decode what your error is. And in fact, you can use what we call error handling, as that is what part of what we'll be learning when we start diving deep into writing the code. Other operations include part payment street receive, manage buy offer, manage sell offer, and so on. If we go on and on looking at the different operations, which is exactly the reason why I did not add it to the slide, is because we have quite enough of operations on the Stellar blockchain that you can basically use. Now, this one is invoke host function. So this is one of the operations you use when you are writing the Soroban smart contract and then you are trying to interact with your deployed smart contract. This is some or one of the operations. So I'm going to drop this link on this Google Meet. And so whenever you want to check out the operation, you can easily go through it at your spare time, and then you can check out the different operations. As during your development time, you definitely at one point or the other need to use or implement one of these operations. And definitely, as you know, the Stellar documentation is the best place you can get the type of resource you want to use to build on the Stellar blockchain. And so you can basically go through there and get that. So I'll stop presenting this and I would start presenting my slide. Okay. So threshold categories and signature weight. So operations fall into 3 threshold categories. We have low, medium, or high. Now, if you check that link I sent to you, at a particular point, you see where they write the threshold, medium. You see where they write the threshold, either it is low, either it is medium, or either it is high. Why exactly is this threshold needed? Or what exactly is the threshold? So each threshold category has a weight between 0 and 256, which determines the required sign weight for the operation to be accepted. Now, if you go back to our class on consensus, each transaction, we understood how quorum worked in that class. And so each transaction is being added to the ledger. But before this transaction is being added, this transaction is being checked. And so this threshold determines whether the required signature weight of the operation called is accepted. If it is not accepted, one of the error codes will be returned from the bunch of operations that I've explained earlier. I am hearing a sound. I don't know if I'm the only one hearing that sound. Okay. Transaction structure. Remember, at the beginning of this class, when we made mention of transaction, I said we were going to talk more on the transaction. And in fact, we are going to understand what this transaction structure looks like. Because we said a transaction is what basically modifies the state of the ledger on the Stellar blockchain. Components of a Stellar transaction. Transactions on Stellar consist of a source account, a sequence number, a list of operations, and an optional memo. What does this mean? This means that the source account initiates the transaction and signs it to authorize the included operation. What does signing a transaction means? I want to see. Signing a transaction means that you use your private key to initiate that transaction. So now, every account created has a private key, a public key, and a public address. The private key is what you use to sign a transaction. Now, different blockchains have different signature scheme. When you talk of Ethereum, Ethereum uses what we call ECDSA for this signature scheme. Now, for Stellar, Stellar uses a different signature scheme. What then is Stellar's signature scheme? Give me a second. It skipped my head right now. Let me quickly get that back. Yes, Stellar uses ED25519 signature scheme. And this particular signature scheme is what it uses for the private key to sign a transaction on the Stellar blockchain. And that is exactly what Stellar uses. Now, the transaction on the ledger, what then does it look like? I'll share my screen again, and this time we'll be looking at the Stellar scan. The Stellar scan, and this would give us intuition on what the Stellar transaction looks like. Okay, let me share my screen on that. I don't know if I'm hearing a sound coming from here. Give me a second on that. Okay. Trying to share my screen on the Stellar scan. Okay. Give me a second for that to come up. The Stellar scan. The Stellar scan. Stellar scan. Yeah. So this is the Stellar scan. Yes, this is what the Stellar scan looks like. So now, for the Stellar scan, the Stellar scan includes what we call transactions. Now, using the Stellar scan, we are going to, this is literally the mainnet. You can switch to the test network. Talking about the mainnet and the test network, we've explained and understood what that means. So here on the Stellar scan, we are going to look at what the ledger looks like. So now, in a full transaction, okay, rather we check a full transaction. Okay, this person requested for link to the Stellar scan. Okay. I'm just going to copy this one and drop that on the chart. Yeah. Okay. This is what we are going to use to understand um, what exactly a noise is coming on, and I do not know where that noise is coming from. And as I can see that everyone here is muted. So yeah. So this is what the stellar scan looks like. Now, for our case, we were talking about what a transaction structure look like. Now, this is what a transaction structure look like. For a transaction structure, every transaction has what we call a ledger hash. Now, the ledger hash is what you use to check for that transaction. So for every transaction, whenever you run a transaction, no matter what type of transaction it is, the transaction returns a ledger hash. And this ledger hash is what you use to check the transaction, basically. It might be that you invoke a smart contract, you deploy a smart contract. Every transaction or any operation you do on the Stellar blockchain, it does what? It returns a transaction. Now, another thing on the ledger is the status. The status literally checks the status of the transaction, whether it is a transaction that is successful or failed. In this case, the transaction we are checking is a failed transaction, as we can see, failed. And so the transaction did not modify the state of the blockchain, but then it is recorded as this scan will catch it. Now, the next one is the ledger number. So the ledger number is basically the block height. So for every newly added block or every in Stellar case, every newly added ledger, it is added to okay. Okay. Anna, can you mute the mic? I'm hearing the sound from your side. Um, Nomad. Yeah, they are basically different. Okay, please, difference between Stellar Scan and Stellar Expert. Now, as I made mention in previous class, there are basically different people that can connect to the network. Now, these people that connect to the network, they are called nodes. Now, when these different nodes connect to the network, they directly have access to all the data that is happening on the blockchain. Now, you as an individual, if you want to serve as a node and you connect to the Stellar blockchain and start participating in the consensus mechanism on the Stellar blockchain, start validating transactions, this means that you have access to all the data that is on the blockchain. This means that if you have access to all the data on the blockchain, you can literally now create a front end and then query all these data you have access to and display it anyhow you want. So you as an individual, you that asked Prince, as an individual, you can create your own scan. As long as you have access to the Stellar blockchain, you can query all the data that is being signed and added to the Stellar blockchain. And once you query all of this data that is added to the Stellar blockchain, automatically you are able to do what? To display it. So the Stellar scan is displaying its own data. Also, Stellar Expert is displaying its own data. So you as an individual can also do this. You can create your own Stellar scan and then display the different data that is happening. This data I'm using, this particular one I'm using, these Stellar chains to the Stellar Chain Explorer to just explain what the transactions in a ledger look like. And that is exactly why I'm using this one. So I stopped at the ledger and I made mention that the ledger is literally the block height. In other blockchains, it's called block height. That's the block number, the current block it's on when this transaction was added. Source account. Now, for every single transaction that happens on a blockchain, all of this transaction is initialized by what we call an EOA. An EOA is an externally owned account, and every externally owned account have a private key and a public key. Let me come again. Every externally owned account has a private key and a public key. And so every transaction initiated on the blockchain, all of these transactions literally is initiated from an EOA. And in this case, the source account for the transaction initialized is this particular EOA. And if you click on this EOA, it's basically going to show you how many XLM the person has, how many transactions the person has, and this is basically the person's account address. I don't know. Nomad, I can hear you typing. I don't know if you can mute your mic or something.
You can hear me typing?
Yeah, I can hear you. I don't know. Are you the one typing? I could literally hear some sound. Yeah, I can. Yeah, I can. Yeah, thank you. It was a little distracting. So basically, you can check out the person's transactions and all of this. And this person is the person that initiated that transaction that we saw, that we read earlier. And so going back to that transaction and using it to explain. So each transaction have a source account, and the source account is the person that initiated the transaction. Also, each transaction has a label. Now, in some cases, certain transaction labels are not added to it. And once the label is not added to it, no problem. No problem. The transaction will still go through. Now, there is also something called the source account sequence. The source account sequence is part of the transactions that is added in the transaction, part of the details that is added to the transaction. Then another one is the fee amount. The fee amount is basically the fee used for the transaction, just as the name stays. Then memo. I'm very sure if most of us are familiar with sending just the XLM from one person or sending to another, the memo basically is usually added. And this memo are usually to verify that a transaction is coming from a certain person. And so imagine I want to send you XLM, I want to send you XLM, then that means I add memo to it. It will ensure that, okay, this transaction is coming from this person, and you can verify that, yes, this transaction I'm sending, this XLM I'm sending is going to this person. Then also, it has the creation date. So for this, it's name created that, and it has, that's the timestamp, the time when this transaction was created. Now, on different transactions, as we've made mention of, each transaction must include an operation. So for every transaction, an operation is called. Now, the operation can now vary since we have different types of operations. The operations can now even be more than one in a transaction. What does this mean? Imagine I have a smart contract, and that smart contract function is referencing or calling another smart contract. And that other smart contract it is calling, it's using an interface to call another function from that smart contract. If it is doing that, then that other smart contract, imagine that other smart contract function it is calling, also have another function in a different smart contract that it is calling. So all of these simultaneous calls result to different operations happening. So more than one operation can happen in a transaction. But in this case, the amount of operations that happened in this transaction is just one, as we can see, just one operation. If you go back and check out more transactions, let's look for one with more operations. Now, we look at the example of this one. This one was a successful transaction, but it had more operations. Look, it had 97 operations. And in fact, it was a successful one. So basically, this is the structure of a transaction. So in a transaction, you must have transaction hash. In this case, it's called ledger hash. In other blockchain, you see it as transaction hash. Then it has a status. Is it successful? And that's exactly why the different operations have a return response. The response is either a success response or an error. And there are different errors, as we have seen, based on different operations. Then the block height, that's the ledger. The ledger is basically the block height, and in this case, is the block number. It's called the ledger. So for other blockchain or other scans, you might see it as the block height or the block number. The block number is also what you can use apart from the transaction hash, which in this case is the ledger hash. The block hash is another component you can basically use to search for a transaction that has happened. So imagine someone sent you a transaction and the person is like, okay, this transaction happened in so block. You can get the block number and basically search for that transaction, query the transaction using the scan, and you can get that transaction on the block. So that is it. Then the source account, I made mention that the source account is the person that initialized or instantiated or called this particular transaction, is the one that created the operation and started this call. So the source account is also part of the transaction. Then the fee amount, the memo, and then the timestamp, then the operations for the transaction. So at this point, this is where we would be stopping for today. I don't know if there are any questions you would like to ask. And okay, I noticed Prince Ebedel is hosting this on, okay, is hosting an activity using, okay, YouTube. Okay, yeah. But this is how we would come to the end of our class for today. And our next class will definitely be on Thursday. And for that Thursday, we are going to have a quiz. And this quiz is quite important, as I made mention in the last class. The quiz is going to, it's going to just be a self-evaluation of yourself. How well have I been following up with what is being taught here? And how well do I know the Stellar blockchain? How well can I, at this level, call myself an elementary developer for Stellar? How well do I have the full knowledge of the Stellar blockchain? As starting from next week, we might be, based on the result of the test, yes, definitely, Kozi, you would be getting this link to the slide. And just as Nomad has always been so helpful in posting all the slides and posting the links to the lectures, because at the end of this lecture, the lecture will be uploaded to YouTube. Posting all of this, you would get the link to it, as you can rewatch the lecture if there's something you do not understand, or even go through the slides again if there's something you do not understand. But for today, we stopped at transaction structure, and then we'll be talking more on transaction structures on Thursday after the quiz. So the quiz will be on Thursday, and if the result coming out from the quiz is a great one, then next week, we will then start seeing introduction to Rust. And then we all can get our hands ready to writing the Rust code, as that is the next step in this lecture. So thank you very much once more, everyone. If there's any question right now, you can ask.
Thank you so much, Ayo. Wonderful class as always.
Yeah, so I'll stop the record now.